Hello everyone, today me, Nordaulet, Yasina and Alimja will present our solution, which is Smart Algae Air Purifier. So starting with, Astana faces a major air pollution crisis, and as of March 2023, it ranked among the world's 15 most polluted major cities, and during its 6-month winter, coal-based heating and traffic create thick smoke, and levels of PM2.5 and NO2 often exceed safe limits by 8 to 20 times, posing serious health risks. Research links NO2 exposure in Astana to a 95% rise in melangian lung cancer, and many residents suffer from respiratory issues. And the World Health Organization estimates that 7 million people die prematurely each year from air pollution, a largely preventable toll, highlighting the importance of CDG3, which is good health and well-being. And Astana's pollution also fuels climate change. In Kazakhstan, CO2 emissions grew over 80% between 2000 and 2014, much of it from coal and oil. And this worsens global warming and environmental instability. To ensure a sustainable future, we must cut emissions, which connects to climate action, and make Astana a more livable city, which is a direct connection to sustainable cities and communities. And our city's pollution is a local emergency with a global consequences. It's time to act, so that's why our project focuses on innovative solutions to clean the air and reduce carbon emissions in Astana.
So our solution is a smart, eco-friendly air purifier powered entirely by the sun, and at its core is chlorella, a powerful type of algae known for its ability to absorb carbon dioxide. But this isn't just a passive system. We have integrated AI sensors that continuously track conditions like light, air pressure, pH, and airflow, and the AI responds in real time, adjusting the environment so the algae always operate at maximum efficiency. Because it's designed to handle both Astana's freezing winters and Almaty's intense heat, it's reliable year-round in any climate. Also, the system directly addresses urban air pollution. As chlorella absorbs CO2, it not only reduces harmful gases but also releases oxygen at a rate comparable to hundreds of trees, but in a much smaller space. The onboard AI ensures everything runs smoothly and efficiently, using only what's needed, no wasted energy or resources. And because the entire system runs on solar power, it's a sustainable solution as it reduces emissions while cleaning the air, so it's smart, scalable, and built for the future.
So, to create our algae-based purifier, we had to combine knowledge from 4 different sciences, each playing an important role in the design and functionality of the system. And the first is the chemistry. We used chemistry to select the right water pH and the nutrient balance to support algae health. Since algae absorb CO2, which forms carbonic acid in water, we had to carefully manage the pH level and ensure that algae receive essential compounds like nitrates and phosphates. Then next, biology. We studied various microalgae and chose chlorella vulgaris because it has a high CO2 absorption rate, fast growth, and strong oxygen output. We also tested how environmental conditions affect its performance, ensuring we choose the most efficient strain. Then the computer science. We created an artificial intelligence model that uses sensor and data tracking to monitor conditions like light, temperature, and CO2 level. The system then automatically adjusts the lighting, airflow, and essential nutrients to maximize CO2 absorptions, all in real time and just in time. And finally, physics. We applied principles of energy efficiency and electricity to design a solar-based system with low-energy LED lighting that makes this air purifier more energy efficiently and environmental friendly. This ensures that our device works all year, even during Astana's dark winters and even at night.
Developing this project was both challenging and incredibly rewarding. One of the biggest hurdles we faced was bringing together 4 completely different scientific disciplines, biology, chemistry, physics, and computer science, into one unified solution. At first, it felt like we were speaking different languages. Biologists talked about algae metabolism, chemists focused on pH levels and reactions, physicists calculated solar energy, and computer scientists worked on algorithms and sensor systems. But as we collaborate, we learned how to integrate our knowledge and rely on each other's strengths. For example, the biologists and chemists worked closely to understand how CO2 absorption would impact water chemistry. The physicists calculated energy needs for the solar panels, and the computer scientists tuned the AI to respond to sensor data in real time. That process taught us the value of interdisciplinary thinking and communication, a skill we know we will use far beyond this project. We also learned a lot from the research itself. We explored sustainable technology, climate science, and CO2 mitigation, not just through theory, but through real cutting-edge studies and innovations. Along the way, we picked up practical skills. We improved our lab techniques by testing algae growth under different conditions. We used Python to simulate how light affects CO2 absorption. We applied physics and engineering by calculating circuits and designing the bioreactor in CAD software. It wasn't always smooth. Our first prototype failed when the algae culture collapsed due to contamination, but that moment taught us about resilience and problem solving. We adjusted for methods, controlled temperature better, and improved our design. This project also gave us a deeper sense of purpose. Mapping our work to the UN Sustainable Development Goals made us realize the real-world impact of what we were doing. We contributed to SDG 3, promoting cleaner air and better health, SDG 11 by imagining greener urban infrastructure, and SDG 13 by working directly on climate action. In the end, this project wasn't just about building an algae air purifier, it was about discovering what collaboration, innovation, and yes-driven science can really achieve. Thank you.